Welcome to Machine Learning Simplified. Today I'm going to take you through a case study that I had solved during my course, which is Postgraduate Diploma in Data Science. I'm going to download the data file from the portal and also a solution that was provided from the institute where I had studied after completing the case study. I'm quickly going through the solution provided step by step, covering the modules. Let me quickly download it. It's going to take a minute there. Okay, looks like I have downloaded it already. Let me switch over to another tab. Okay, I'm going to close this now and let me look at the case study provided by my institute. Just like I mentioned, I'm quickly going to take you through the solution provided step by step, covering the modules, starting with loading libraries like NumPy, Pandas, and the data headers. And then data cleaning and preparation. Exploratory data analysis and steps and dummy variable creation, creating a test train split. It's a lengthy process, as you can see over here. Scaling, correlations, model building using logistic regression and optimizing it. Let me scroll further. Model evaluation, checking the optimal cutoff, the ROC curve, making predictions on the test set. Scrolling further, testing precision and recall, making predictions on the test set, and finally checking the overall accuracy of score, which is 78% as shown over here. And lastly, the confusion matrix, precision, and recall. You can also see the scores over here. I'm going to switch over to a new notebook and start with importing the data, which is the CSV file, into this notebook. I'm going to type import pandas as PD, and I'm going to import the CSV file using lead data, which is a data frame, and I'm going to type pd.read_csv, and then the name of the file, leads.csv. Oops, okay, let me quickly connect my battery. And the next one is loading the header of the data frame to quickly look at how the data is. And converted is the target column over here, which is the target variable, which is the y. And let me import PyCaret. Let me see the syntax. Okay, from PyCaret dot classification. Oops. Okay. Import star data1 equals setup lead data. Oh, okay. Yes, using data. And target is going to be converted. I want that column as the target because that's the result that I'm going to look at. Okay, and there you go. It starts evaluating the data that is present, and it's going to load the dependencies, as you can see over here. Waiting for it to load. It's going to take up a couple of seconds or even more. Still loading. I'm going to wait until it completely loads, and there you go. It has loaded. Okay, so following data type have been inferred automatically. If they are correct, enter to continue. I'm going to press enter, but I'm just going to look at the columns. As you can see over here, converted is label, rest of them are categorical or numerical columns. I'm going to hit press enter and then move on to the spot where I'm going to compare the models. Look at this very carefully. The moment I enter this code that is compare._models, it is quickly going to start evaluating the data, and it is going to prepare a machine learning algorithms. Not one, not two. It is going to prepare 15 different algorithms based on this data set, and then going to compare it one by one and rank it on the scale of 1 to 15. It's going to take some time, and since it's a computationally expensive, okay, I'm going to wait until it starts loading. As you can see over here, my CPU and memory and disk and GPU all are completely loaded because of the computations that is currently being carried on. Okay, let me load. Let me skip over to this part where, as you can see over here, the decision tree, classifier, and the other algorithms are already being processed, and you can see there's some error. I'll look into this later. It says SVD did not converge. I don't know what the hell is this, but maybe there's something wrong with the data, maybe. And that's where it has stopped, linear discrimination analysis. And as you can see over here, decision tree classifier has the highest accuracy, but if I look back into the solution provided, as you can see over here, it's just 78%. So if we had used decision tree classifier, it would be much higher. And as you can see over here, logistic regression with a couple of lines of codes already got a score of 70+%, which is really good. I'm surprised to see this, how it works and how it compares and ranks different machine learning algorithms to assess the scores and finally provide the output. We're not going to stop here. Even though there is an error, we are still going to proceed with the existing scores of the algorithms by creating a model for logistic regression, because that's what I want to check. Okay, I'm going to create it and waiting for it to load. Okay, as you can see over here, the accuracy, AOC, recall, precision, F1 and kappa has started loading. This is basically the iterations of the same. Let me okay, my CPU is heating up, so I'm going to switch on some cooling over here, and okay, it's still loading. it also shows the estimated time to complete. It's probably going to load I think 10 iterations and then going to show me the mean. Okay, there you go, it's completed. Okay, and the mean is 72%, as you can see over here, and the kappa and F1 I'm still looking into it, but all the other parameters which matter is a lot is the accuracy and recall and precision. So I'm going to further tune it, which is usually referred to as hyperparameter tuning. I'm going to tune this model again with just one line of code. Tuned LR, tune model, and then LR, which is logistic regression. And I want it to be optimized based on accuracy. So I'm going to mention it as optimize accuracy. And there you go. It is already tuning the hyperparameters. Again, this is going to take a while. Not too long, just a couple of seconds, I would think. Let's wait here until it loads. Again, this is a computationally expensive task. Okay, I'm just going to wait for it to show me at least the etc. And this notebook is being processed on my laptop, a 7-year-old laptop, which is having the configuration of a Core i7. Let me quickly look into it. Okay, let me open my computer. It's taking some time to load. I think it's overloading my CPU. Not sure. Let me check. Okay, it's not allowing me to open anything. I'll take a second over here. Let me try again. Oops, it's not opening. Oh, it's not responding. Okay, I think I'll have to wait until it loads. It's still loading. I still don't have the etc. My god. Meanwhile, it loads. I think you can also use Google's Colab. That is again an online cloud-based notebook where you can do all these kind of computing tasks. Again, it will take some time over there depending on the load it already has. So you can try that probably. Okay, I'm still going to wait. Okay, it's not allowing me to do anything. Okay. Let me stop the recording over here and probably switch over. Oh, there you go. The etc has arrived. It says 40 seconds. Yeah, 33. I'm still not able to select anything, maybe because it's completely occupied my memory. Okay, it's close to end. The hyperparameter tuning is almost going to complete. You can see, I just have to do one thing, which is wait after typing a few lines of code. Again, that's what I can do the least, compared to the previous method where I had to sit for hours, code and code and code, data cleaning and so on. Okay, as you can see over here, the 75% of accuracy is still not bad with the logistic regression. that is being carried out. So I'm going to quickly plot model, which is logistic regression. I will later explain about this process, why, how, and why this is being used. Okay, so there you go. That's the ROC curve. It didn't take me more than a second. Okay, I'm going to plot it again on the tuned logistic regression, which is the hyperparameter tuned. Module, okay, and evaluate model, that is on the tuned logistic regression. And there you go. This is the most interesting part, where you can see multiple things at a time. For example, hyperparameters, AUC, confusion matrix, feature selection, and so much more. You can see over here, right? I don't know most of the things here, which is like manifold learning, but yeah, you can see confusion matrix, precision recall with the chart. Again, you don't have to type any syntax over here. Okay, feature selection. I know this is going to take a while. Okay, there you go. It started loading already. Okay, let me check if I can open anything now. Still no. Okay, I'll try to switch over. Okay, still not able to do anything. Maybe it has taken a lot of resources. Let me quickly go to my screen recording, try to stop it. I'll quickly switch over. Oh, it's not allowing me to do anything. Let me take a pause here. Come on. Come on. Okay. I'm going to try again. Okay, meanwhile, I think it's good that we can go through the library, PyCaret. That's the library which is enabling me to do all these things, right? So you can go through this website, that is pycaret.org, to go through this open source machine learning algorithm, which is a highly productive method of training machine learning algorithms. You can go through the site, you can go through the steps on how to initialize, train, and going through analysis and model deployment as well. This also has other interesting features like natural language processing, NLP. I'll go through that later. Probably you can check the site and go through it in detail. But yeah, this is what it has all. So yeah, supervised machine learning and then unsupervised one here, natural language processing. Okay, just like I mentioned, is an interesting part. You can have a look at it later. Okay, I'm going to just get started with it on how to load. These are basically the data sets which the site is already providing, and you can import these data sets to start checking your machine learning skills, basically. It is so much easy now. So yeah, this is the NLP. Yep, you also get the starter code so that you can just copy and paste it onto your notebook and quickly get started to train your algorithms and deploy it. Also, there are a number of other libraries in Python. One of them is Numba, which is a very interesting library. It's not the Python that is really fast. It's the libraries that make it really, really fast. And this one is, again, very specific to scientific computing. You can try working on this. I had seen a conference, I think online, maybe, yeah. if I recollect. And this library had helped the developers compile and train ML, which took them more than like 1 year in a couple of minutes. I think that's it. Thank you, guys.